Synthetic division is an alternate division process compared to polynomial long division. And what synthetic division does is it uses the process of just multiplication and addition of numbers to simplify this process of polynomial long division. The real advantage of synthetic division is that everything is simplified to simple multiplications and additions, and all of the variables are going to be removed during this process. Since we've removed all the variables in the process of synthetic division works a lot faster than polynomial long division does. However, this comes with a bit of a drawback. Synthetic division, in our course, we're only going to focus on linear factors of the form x minus c. If ever we have to divide a polynomial by something larger, like a quadratic or a cubic factor, synthetic division is not going to be able to do this for us. I think the best way to explain the process of synthetic division is to see a couple examples. In the first example, we're going to write down some of the preliminary steps that we need before we can start the process. First thing to do is draw yourself an upside down division brace, and then we're going to transfer the coefficients of our first polynomial into this upside down division brace. After you've inserted these coefficients into the division brace, we're going to take a look at our linear term, and we're going to take the opposite number that's inside of our bracket. So here it's 3, but we're going to take the number -3, and that's what's going to go outside of our division brace. From here, we bring down our first coefficient. In this example, it's 1, and then we start the process of multiplications and additions. -3 times 1 is -3. 5 plus -3 is 2. -3 times 2 is -6. And 6 plus -6 is 0. Once we've done our last addition over on the right-hand side of the brace, the process is complete, and we have to figure out what these numbers, 1, 2, and 0, actually mean. Let's start over here on the right-hand side where we have the final number of 0. This number that's the furthest to the right represents the remainder of the division that we've just done. In our case, we have a 0 remainder. Then, all of the numbers to the left of our remainder represent a new polynomial that we get from this division. In this case, we get a quotient polynomial that is of the form x plus 2. So in order for us to figure out what this polynomial looks like, we go back to our original polynomial that we were dividing. We look at the degree. In this case, the highest degree is 2. So this first number represents the coefficient of a polynomial that is 1 degree less than what we started with. In other words, this column represents the coefficient of the x, this column represents our constant term, and this column represents our remainder. In our next example, we're going to take the polynomial 2x squared minus 5x plus 7 and try to divide this by the linear factor x minus 2. So to start off for synthetic division, we're going to write down our upside down brace, and we're going to take the coefficients of our first polynomial. So we need 2, -5, and 7. Remember that the value that we take from our linear factor is going to be the opposite of what's in our bracket here. So we're going to take +2 to be on the outside of our division brace. We bring down our first term, which is 2, and then we start the multiplication and addition process. 2 times 2 is 4. Then we have -5 plus 4. That's going to be -1. We have 2 times -1. That's -2. And then 7 plus -2 is equal to 5. Remember that each one of these numbers gives us information about our final division answer. Firstly, this 5 tells us the remainder. And the 2 and the -1 tell us our coefficients of the quotient polynomial. Since we began with a degree 2 polynomial, this 2 must line up with x. So 2 is going to be the coefficient of an x term, and negative 1 is going to be our constant term. 5 is our remainder, so 5 is going to be put into our final answer like this. Really, we have 5 x minus 2's left over after we've done our division. An alternate way of writing this final equality that I have is the following. We could say that 2x squared minus 5x plus 7 is equal to the multiplication of 2x minus 1 times x minus 2 with a remainder of 5. In our last example, we're going to divide the polynomial negative 4x cubed plus 40x minus 1 by the linear factor x plus 3. As before, we're going to begin by writing down our division brace and transferring the coefficients of our first polynomial over. So we write down negative 4 to represent our x cubed. Since we don't have an x squared term, we're going to put in a place value holder of 0. Then our 40 here is going to represent the coefficient in front of x. And then finally, negative 1 is our constant. Since we have x plus 3, a negative 3 is going to be put over here on the left-hand side of our brace. We begin by bringing our negative 4 down, and then we start the multiplication and addition process. Negative 3 times negative 4 is 12. 0 plus 12 is 12. Negative 3 times 12 is negative 36. 40 plus negative 36 is 4. Negative 3 times 4 is negative 12. And then finally, negative 1 plus negative 12 is negative 13. As usual, our furthest right number represents the remainder of this division. As we move to the left, this 4 is going to represent the constant term of our quotient. 12 represents the coefficient of the x term in our quotient. And negative 4 represents the coefficient of the x squared term in our quotient. So remember that there are two different ways that we could show this relationship. First, we could take our original question and say that this division is equal to negative 4x squared plus 12x plus 4 minus 13 over x plus 3. So here's the remainder of our division. Or alternatively, we could say that this polynomial that we started with is equal to the multiplication of the quotient that we got, negative 4x squared plus 12x plus 4, times that linear factor x plus 3, and then we have this remainder of negative 13. All right, my little epsilons, stay positive.